Hello, Sir Dimas. This is our networking project. I'm joined here with Hassan.
Hello.
We're going to show off our load balancer program. It's a high-level load balancer that balances HTTP requests between 5 servers. Hassan here will explain how it works, and we'll go on from there.
Yeah, so if you look at the diagram, we have our client. It sends an HTTP request to our load balancer. Our load balancer uses a round robin algorithm to balance the traffic. So it sends equals to each server, which then no server gets overbalanced. And it also runs a phone job every 5 seconds to check the health of each server. And if the server is down, it makes sure to skip that algorithm.
Yes, correct. So our load balancer is acting as a reverse proxy to the client's HTTP request, and the client won't know which server it's running, but or which server it's going to hit, but it's going to make sure it hits a healthy one, since we're having a cron job that makes sure the servers only being served to healthy servers. Okay, so without further ado, let's go to the program. So the program is done on Golang. So if we go to the main Go, this is our main function. So this is where all the program gets executed first. It's our entry point. And when we make the servers, we use a helper function called makeServer. Here it defines our routes. So we have home, which just returns some HTML that we define in another file. However, this is one route handler that I made to shut down the server to just test if the health check works. Since we're using Go, we can use concurrency. Concurrency lets us do multi-threaded programming, and so we can run many servers simultaneously using wait groups here. So this is the main Go routine, you can call it, and we're running many Go routines. We're using wait groups to wait for our Go routines to finish. You can see we have here in line 55 wd.done. When our make server is finished, it's going to launch this, and then it's going to yield back to the main Go routine, which is run many servers, and it's going to wait, and it's finally going to have the servers running. So after that, we can just show off how it works with Docker Compose. Since all of this is pushed to the Docker Hub, we have the servers image on Docker Hub, and then we have the load balancer image on Docker Hub. So let's go ahead and run this. All right, so our servers are running simultaneously, and we have the cron job every 5 seconds looking at the health of the server. Hassan, did you want to go to localhost 8090 and check the load balancer?
And then set up. So,
Yeah.
so refresh it. See both servers.
Yeah, so every time we refresh, every server's hit round robin style, as you can see. However, Hassan, what happens if we shut down one of the servers?
So shut down.
Okay.
Check on it.
First, look at the cron job health.
Oh yeah.
So we can see that server 2 is not healthy. So server 2 should not be hit anymore on the load balancer. So you can see, yeah, server 2 is being skipped. You might as well shut down another server, see if that works. Okay, now server 3 is going to be shut down. And server 3 is not healthy.
Turn all of them.
There we go. So this is our simple load balancer. It handles high-level requests like HTTP, and HTTP, the backbone of it relies on TCP as well, so we're using TCP as well. And we can also show the diagram for Docker Compose. So this is our Docker Compose diagram. We have two services running for Breezy servers and for Breezy Load Balancer. Along with them, it has its interface @0 and our public IP addresses. They're different, and we can view them in the containers for our next segment when we go into them. And they're connected with the networking bridge provided to us by Docker Compose, its default networking bridge. So in these containers, the main communication is between the load balancer, making sure that the servers are healthy and that they are accepting HTTP requests and making that TCP connection. And also making sure that we can also shut them down. These containers are also by default configured to our ports, matching respectively what they are running on. So 8080 on the Docker container is 8080 on the local host. And yeah, the next section is going to be showing us going into these containers and looking at the networking statistics. Okay, so now that we have our containers running with Docker Compose, we can check that by using Docker PS command, and we can see that they are running. So now we can go into them using Docker exec and using their container ID. And this is for our load balancer. Up next will be for our servers. Okay, and now we can check the IP address. So to search the IP addresses, we're going to have to go into the etc directory. So we can just go back one, go into etc, and then we can cat the hosts. And what this file does, it shows you what it maps IP addresses to. So localhost is 127.0.0.1, and in this case, this is the public IP address for our container, and this is the container ID that it maps to. We can also check for the servers as well, the servers container. So we can go back, go to etc, the host, and you can see that this is a different IP address than our load balancer, and it maps it to the container ID of the servers. Now we can also check how these communicate to each other. So if we go back and we go to the app and we see our load balancer, and we can go ahead and see what's inside of it. And we can see that the load balancer is actually talking to our our servers by its container name. So instead of referencing to our server by its IP addresses, what we're doing is using the server or the container name of the service to communicate with it. The reason why is because Docker Compose makes a network that configures the host name of our container, or in this case, it's the service, right? Our service name. It makes that a host name and it maps it to the IP address. So that is how the load balancer is communicating to our container and communicating with every server. And yeah, let's go ahead and check how the web traffic is on the load balancer. This is the load balancer. We can go to netstat-a and see that all of the connections that are being processed, and we can see that the load balancer is going through 8081, 8083. All of these are being established because of the cron job that every 5 seconds it's going to check the servers to make sure the health is right. We can also see here the routing table. We can see that this is the gateway. This is the flags, meaning it's up and running and has a gateway interface. So yeah, this would be the routing tables. We could say the same for the load balancer here. And they're similar because they are running on the same network using the default network bridge. And yeah, that about does it. It matches our diagram here for our Docker Compose. And thank you for watching our presentation.